Okay, so I said I would make a video in regards to my batteries. These are lithium batteries. They are the EG4-LL LifePower4 model. They come in at 24 volts, 200 amps, or 25.6 volts to be exact, 200 amps, 5,120 watt hours. So you've got 5 kilowatts in each battery. Now they are 24 volt batteries, and I do have a 48 volt system. My inverters are 48 volts, so to communicate with my 48 volt inverters, I have to string two of these 24 volt batteries in series. That'll give me the 48 volts that I need, or 51.2 volts, I believe it is, at 200 amps. Remember, your volts increase when they're in series. Some of you might wonder, well, why did you buy 24 volt batteries when you have a 48 volt system? It's a really good question. One, they didn't have any 48 volt batteries available. And two, I plan on building a greenhouse where I plan on implementing a 24 volt system. So the redundancy for me using it for my in-house solar system and my greenhouse system kind of worked out for me with a 24 volt battery. If I could do it all over again just for the house and for this 48 volt system, I would have went with the 48 volt 100 amp batteries. Now my overall opinion of these batteries is pretty good. They haven't given me any issues as far as operation goes. The 200 amps seems to cycle through really well. Supposedly they do come with 7,000 cycle capabilities. I don't know if that's true or not. They haven't been on the market that long, so I guess time will tell. These particular batteries supposedly come with a 10-year warranty. Now, I bought them from Solar Signature, and if any of you have been looking at the LifePower4, the EG4-LL batteries coming out of China, you'll realize that a lot of the descriptions and manuals don't make a lot of sense. You got a lot of cut and paste, and they're not very thorough, whether they have the fuse on the outside of them or not. These particular batteries, as you can see, when I did receive the instructions, they actually show that they're LifePower4 batteries that come with the fuse, the breaker on the outside. Now, when I looked deep into the web to find out if this particular model of battery actually has the fuse, it says that it actually has it built in. The manual that I have doesn't show that it's built in, shows that it's on the outside. Getting information in regards to the exact information in regards to what you bought coming out of this particular series of batteries, it's not so thoroughly exact. You're going to have to find the information. Maybe now they've printed it to match the batteries they're actually selling, but I doubt it. A couple of nice features with these batteries. Obviously, they're plug and play. That built-in battery management system works extremely well. I was analyzing these batteries, trying to get them to communicate with the inverters, which we'll go into a little more detail on, and I couldn't do it. But there is a software program available where you can plug in your computer, download the software, install it, and then use a RJ45 or an Ethernet 5 cable, connect it to the software, your computer, and each battery, and it'll show you exactly what's going on with the discharge and the charge, and you can kind of get an idea how they're cycling through, which is pretty nice. You're supposed to be able to read them all in one format, but I can't. I've tried everything, couldn't do it. So just a general overview here, what I've done. So you can see that I have strung two of these batteries in series. So I have the negative going to a positive, and the one positive going to the bus bar, and one negative going to the bus bar, and then of course I repeated it here. So you have two of these batteries running in series. That makes 48 volts. They're 24 volts each, or 25.6 to be exact. String them both together in series makes 48 volts. That goes to my bus bar. Remember, the amps stay the same, so it'll be 200 amps. Goes to a negative bus bar. This goes to a positive bus bar. I do have one of these bus bars open, so you can see the connection here. The instructions call for grounding everything. So I did ground each of these. So you have each one grounded to itself, grounded to the actual, down below it's grounded to the chassis. Down here the final ground goes down to the chassis, and then the chassis underneath this plate in the corner I have grounded actually to my bus bar on the top, the grounding bus bar that goes out to a rod about 100 yards from the house. Now, these Ethernet cables are here in place in order for the communication between batteries. That's supposed to work with the software and with each battery, and then you connect it with this yellow one to the inverters. That doesn't work. It's one of the issues with these particular EG4 batteries in communication with Growatt inverters. They do not work. I will show you how the software runs though, where you can get around it and actually communicate with them individually with the software and your computer. Now you can see I ran from the top of the main bus bar. Basically it connects over here. You can see to the top of the bus bar. I ran them through a piece of conduit just in case they would get heated up, seeing as I do have wood on the top of this battery compartment. I didn't want to have any issues, nor do I want any type of cabling with so many amps and volts going through it to get frayed, touch any of the metal, and have an issue. So just for my own concerns, I put them in PVC piping just so that they wouldn't touch if there was an issue. Beautiful case for this particular type batteries. Yeah, these batteries are expensive, as I said, but if you start piecing them together and buying your own battery management systems, it's going to get pricey, it's going to get complicated. And going into some of the review that I had over some of the other batteries that other people have torn apart, you can see the components inside looked pretty good. So I was more than willing to pay a little more and have peace of mind, and that peace of mind so far has come. But in regards to the case, so I bought this metal case. It didn't come with a door, and as you can see, it didn't come with a bottom here, so I put it up on 2x4s on the bottom. I put a wood plate on the bottom. Just I was setting some papers in there, but seeing as there's a lot of electricity, it's not a good idea, so I just put a floor in there. The door I actually had to make. Didn't come with a door, nor did they have them available. I just made that out of some type of a plastic that I had in the garage. As you can see, I made a wood protector. Basically, it only serves as a backup emergency if somebody tripped, were to fall into this cable system, water, any type of debris. Basically, I have a secondary set of protection that will help me protect these components that are electrical components. And you just take that off and we can display the core. Maybe you want to see what I did here. Pretty basic setup. Be nicer if it was plastic, because plastic's not as flammable as wood, but hey, that's what I have. Now you can see that this Ethernet has a port. It has a COM port, and it has an RJ485 port, I believe it is. Neither work. I've tried everything. I'm a network engineer, so I know how communication goes, and you can't get these things to communicate with the inverters and the batteries for nothing. You have to build an entirely separate communication card for it to actually work. Why do I have this in there? Because I haven't pulled this thing out in order to unplug the RJ45 cable, otherwise I would. So let's get into the details of the connection of these batteries when they're communicating with the inverters. Okay, so now we have the batteries cabled to the inverter. You're going to have to tell the inverter what kind of batteries are cabled to it, right? In this case, we have lithium batteries, and one of the selling points, of course, is Growatt, that it communicates. The battery management software in here will actually communicate with the battery management software of the batteries. Well, that's not the case with this particular Growatt and those particular batteries with this lithium setting. So let's go into our settings here just to see what we got going. And in setting 5, basically user defined. I can go in here, I can change this to flooded, AGM, whatever your batteries may be. I believe this is user defined 2 setting. I'm not sure exactly, I have to check in the manual. And then you have lithium. Well, I have lithium, but it doesn't work. If you leave it at that, I believe you get an error message. I can't remember. My biggest concern was that if I leave this at lithium, I won't be able to manage options 19, 20, and 21, I believe, which are the charging voltage. I believe it's your float charge and your discharge voltage shut off. I think we'll get into those in a second. So I went to user defined because in L1 lithium, the inverter is supposed to do it for you, but it doesn't work with these particular batteries. So you've got to go to user defined, and that's where we get over here. So we have it at user defined, which will allow us to get to 19, 20, and 21, I believe here. So at 19, so what is this number 19 here? The manual says it's charging voltage. So actually I have a charging voltage of 56.4. I'm actually going to lower that to roughly 54. There's nothing wrong with that, so I'll do that right with you. If it actually allows me to keep it at 54, it probably does. So I'm going to check that, leave it at 54. 54 is fine for that setting. That way it doesn't have to charge at 56.4. It can actually charge down to 54. I believe it'll charge all the way down to 47 or 46, if I'm not mistaken. You have to check with whatever batteries you get, but these particular batteries, I believe in the spec sheet, it'll go down to 46 point something. So we have that set at 54, the charge. The float, basically that's going to be where it's going to maintain, so you'll have basically a trickle charge on your float. That floating value basically is it's a method of maintaining the battery in the charged condition by continually applying voltage or current at a minimum level to maintain a full or near full capacity. I have that set at 54 as well. And let's go up here to 21 is low DC cutoff voltage. So in the manual it actually says here, it gives you 3 options for your low voltage. Basically it's going to shut it off if this is receiving less than 42 volts, basically it's going to shut everything down. And that's option 1. The second option would be that the PV energy and battery power are available. Inverter will charge battery without AC input. Okay, that's obviously if the PV and the batteries have the capacity. If the PV and battery power and utility are available, inverter will transfer to line mode and provide output power to loads and charge the battery at the same time. One of the other things you're going to have to do when you configure these batteries is you're going to have to be able to tell them how are they going to communicate with the inverter, how are they going to communicate in between each other. Well, you have the Ethernet cable here that's going to do some of the communication, but between this battery and this battery they have to talk. Well, it needs to send some kind of a language. How does it do that? You have a manual setting here of dip switches. Each one of them is going to be different as you go down all the way to the bottom. When they're all the way down, that's on. When they're up, that's off. And I'll take you to the configuration on how you configure those up here. So the user manual for these particular batteries, I bought them from Signature Solar, like I said. So you have to go to Signature Solar's website here. You go to the full spec and full menu of your batteries here. So you click on this is a particular battery I have for the spec sheet. Click on that, it'll download and take you to, I believe, let's see here, take you to this particular manual. Okay, so here's the actual manual. This is the lovely part of buying these batteries. So this is the actual manual for the 24 volt EG4 manual. And what you'll realize is basically it lists the 24 volt 200 here, but when you actually go down to the dip switch settings, which are these ones right here, table 3.4 here, assignment, it's actually set up for the 48 volt. So is that an issue? Well, it can be, because when you configure these batteries to communicate together in the software, it should list here all of your batteries. And one of the reasons it might not do it correctly would be the dip switch settings might not be correct, or the actual Growatt inverters communication tool isn't able to pick them up either. Anyway you look at it, this is the only manual you have available for this particular battery, so you're going to have to run with the dip switch settings the way they are. Now it tells you how to configure the dip switches. So number 1, 2, and 3 are on. 1, 2, 3, 4 are on module 1. Well, I have 1, 2, 3, and 4 on, but it still shows up as number 16 when I have the Ethernet connected there, the RS-485 jack they call it, and we go over to the software that allows my computer to communicate with those batteries, and you get, basically you do a search device, which I did, make sure we're connected to the right battery, and I'm pretty sure it is. So each battery will actually have a serial number. It'll actually match, I believe there's a sticker on the battery that'll actually match that serial number if you have any doubts of which one you're connected to. If you don't trust the cable that's connected there, it'll tell you the model of the actual battery. You have to put it on a baud rate of 9600 to get it to communicate, and pack number 16 is automatic default that this one comes to. You could put it on. I believe I had to set it on COM 5 to get it to communicate. I did have to play around with my USB settings on my computer to get it work. It defaulted to COM 3. That didn't work, so I went to COM 5 and used a different USB, and it worked fine. So anyways, over here you'll see the one battery. It should say module 1. That's what the dip switches are set for, but it doesn't. I've screwed around with these settings and dip switches. I've tried a little bit of everything. Now I can get it to change numbers, but what are you changing to? You're basically shooting at the dark here, because I'm guessing that this particular table goes with the 48 volt battery, which it says it does, even though it's a 24 volt manual. That's part of the issues I have with these particular batteries, but I can go get around it. I mean, I really do like the battery. This is one little issue that thankfully the battery management system works accordingly, otherwise this would be an issue. So you go down the list, you this number 2 here, or address number 1, is actually reserved for the communication of the inverter, so don't set any of them to on, off. Yeah, that'll be number 1, and then the inverters, I imagine, won't be able to have any type of communication with the batteries. And what do I mean by communication? These inverters are obviously pulling in electricity from the solar panels. They're sending current to the batteries, and they're also sending signals to and from the batteries. Now we're not getting the full battery management system that these have the capabilities of processing, and battery management system of these batteries have for communicating and processing, but we do thankfully have the correct battery management systems where these batteries, each with their battery management system, are sending a signal through the line saying, hey, to these inverters, I'm full, I don't need any more electricity, so stop sending to me, and it automatically shuts off here. That's not any software going on with the inverter that should be going on if these communication ports, the RS-45 or the CAN port that's connected to the inverters, if they were actually functioning, it should actually take care of that process as well, which would be a very nice redundant backup management system, but it doesn't do that. So you have to configure your inverters on user mode, because it doesn't work with the lithium mode with these particular batteries. It's another issue I have with these EG4-LL LifePower4 batteries and the Growatt. Now I've seen other guys that are running other inverters and the EG4s don't have a problem with communication, but this particular Growatt that I have, inverter, it does have an issue and it's not doing the communication like it should. But like I said, the management software in these batteries and the inverters is good enough to say, hey, I need electricity, depending on what you're programming this to. I need electricity. Start sending electricity and basically charge me up. And if I'm full, shut me off so they don't overcharge. So you've got the overcharge and undercharge protection values built in there. Nothing to do with the actual components being able to communicate between each other, so they're independently using their own battery management software in order to do what they were designed to do. So anyways, we go back to the dip switch configurations. As you go down the line, you can see I have this one set up which should be number 2, so it should be on, off, on. Number 3, on, off, off. And then number 4, I have on, off, on. Now, let's go back to the software here. And you can see. So, this is pretty cool because it tells you exactly what's going on with the batteries. Right now, so we're discharging. If I go up to one of the inverters and actually look, the heater down here turned on, so I have a 240 volt heater sucking off the system. So you can see it's actually pulling in 51% of the capacity of the inverter going to servicing this 240 volt heater. So I'm obviously bringing in more, I'm bringing in a lot less amps than I'm actually kicking out. Cycle through here. We can actually see, this is a pretty good display. So I'm only bringing in roughly 4.5 amps, 216 watts, which is nothing. 4.5 amps literally. And the house is consuming, or at least this electricity that's going to the heater is consuming 12.6 on this one and probably 12.6 on the other. As you can hear, the inverters are actually kicking on. Okay, so this is the cable I'm using to connect my computer to the batteries to communicate with them. Basically, you take this Ethernet connection, connect it to the RS-485 port. This is the USB connector. Probably wondering why it's taped. Well, I had to buy this. I bought this component off eBay. It allows me to string 2 wires to the 2 wires that are on here that'll correspond in this port and allow me to communicate with the software. So we'll take this, we'll connect this to the laptop. Should get some lights. You get those flashing lights, means that it's actually communicating, and that'll allow me to talk to the first battery. Now you'll have to download the software. This is the actual software that comes from Growatt. I can't remember where I downloaded it. I searched for it somewhere on the internet. Basically, this is the icon for it. It's called BMS Tools 15-6. This is version 2.06. I don't know if they have an earlier version or not. Basically, you plug that USB in, plug the other end into the first battery into the RS-485 port, and open up the software. Then you have to search device up here in the corner. So search usually takes a few seconds here. You can see it processing as it's doing its communication. Now you're supposed to be able to communicate with all the batteries on the series. That's one of the reasons you have each of these batteries communicating with the COM ports, so they can actually see all batteries in the same series. Now, I've tried every which way up, down, and around to get them to communicate under the same pack. You can see over here you have pack. Well, I've seen other videos where I think it's Signature Solar, one of the guys over there, he actually has connected them and he's able to read all of them coming down. I've tried everything in communicating. If somebody knows the secret on how to get all of them to list at the same time here and give the display, please let me know. I've tried everything, every configuration, tried all the different cables. I've screwed around with every little apparatus you can in order to get them to communicate. I can't get it to communicate, so I have to do them one by one, which is fine with me. So it's also not identified. Pack 16, you're supposed to be able to set the dip switches in these. I can set the dip switch and get it to actually communicate with battery number 1, but it makes no difference when I do for the series. So basically I'm set up to see. It's charging right now. Right here you can see this green battery status on this particular battery is discharging. If it was charging, I would say charging here, and it tells me the state of charge, 37%. This is the state of health. It was actually 100%. That I'm sure will go down depending on how many times you're cycling through the process of the batteries. You can see the voltage running through there, the current amp, yeah, the capacity of amps, and amp hours remaining. So you can see the state of charge here actually says 37%. The state of health 100%. So this 37% tells me exactly what state of charge is this particular battery that we're plugged into. Now you can see the little LEDs here. Each LED says basically 25%, 50%, 75%, and 100%. If they're all lit, it would be 100% charged. It has 2 of them lit, meaning it's at 50% charged, which isn't quite correct, but given you know, it doesn't have the detail of the LED, which we'd of course like, we can see that it's actually 37% is actual state of charge. And this breaks it down on each cell, which is pretty cool. So you got 16 cell batteries here. You can see the volts on each cell, which is pretty cool. You can tell you the temperature down here, which is pretty nice. And then there's a lot of other parameters and controls, but you can't configure those, or at least you shouldn't. I haven't really screwed around with them. It tells you not to screw with them, and basically avoid warranty with a lot of them. So let's do this. Let's, for learning reasons, let's disconnect the RS-485. Let's put it into a number 2 battery. Let's go back up here. Let's run the search for device, and unfortunately I have to do this with every single battery. Like I say, the guy at Signature Solar, he has them configured where he can just click it once and it'll go through the communication of the RS-485 or Cat5 cable and communicate with all of them and give them a display of every single one of them at the same time. If somebody knows the trick, please let me know, because it is a little inconvenient when you're trying to actually just check out the state of charge on your batteries. So this one did the search device. It should come up with a different battery. It does. It says pack 2, so we click on it. It says online. Now it says it's charging. Obviously the heater kicked off, the 240 volt heater, so now it's actually charging. This battery's at 38% as opposed to the 37 on the other one. And let's see here. Where's the LED lights on this one are with the 2 LEDs as well. So you kind of get an idea, and we can go down the list and find out the state of charge. One thing I did, because the communication software between the inverter and battery isn't working like it should with these particular EG4s, I connected to each of these batteries at the time of charge, discharge, and I fully discharged those batteries to literally 2% to see if they would kick on automatically to the settings that I set in the inverter, and they did. I'm sorry, what the battery management software kicks on and does automatically for you, and it did. Obviously, you drain the lithium battery to 0, you're probably gonna kill the battery completely, so I wanted to make sure that didn't happen. So I actually monitored it. I also monitored as they were charging, did they shut off at 100%? And absolutely they do, each one of them. And the other interesting question I had was, given that you're connected at the top here of the bus, the electricity is first going to service the closest cable to it, right? Well, it does. It'll discharge and charge these batteries first. because you have the bus line here. So I thought, well, if it charges these ones to 100%, and these ones are roughly lagging, they roughly lag 3 to 4% behind the top two batteries that are closer. Will these ones shut off and allow these ones to continue to charge? Absolutely. I watched it actually happen. So it'll shut, these batteries will say, hey, I'm full. It'll go down to these ones, and these ones are still, 4 to 5% remaining, and they'll continue to go until they're 100%, and then they'll shut off. So the battery management software on these batteries is really well. They work correctly. But for communication between the Growatt and EG4s, I can't get it to work. If somebody else can and knows a trick, please let me know, because it'd be nice to actually take advantage of the full capabilities of the lithium setting on these Growatt. And that concludes this setup. Again, happy DIYing. Again, I really enjoy this system. The full system, the panels are capable of producing 7,000 watts, 7K. Batteries right now are 20K. You have 4 of them at 5,000 watts each. Is it enough power? Well, it's never enough power, right? I have about $10,000 into this system so far. 2 inverters, 24 panels, and 4 batteries at $1,500 a pop. That's 6,000 in batteries. Yeah, I could use a couple more. You could probably use another minimum 12 panels as well. I noticed in the winter months here that they produce really well, as long as it's not snowing, right? The amount of energy in the PV, the snow, I believe, ricochets some of the sunlight and actually amplifies the light emission to the actual cells of the panels. So that's actually a plus. And I also have the panel set at 39 degrees, which takes advantage of this time of year. So I'm actually getting a lot of juice and power to those panels that aren't movable. I'll make another video on actual panel setups and what I did and how I did it and why I did it. But yeah, that concludes this part. You guys have fun, enjoy. Can't stress enough to be extremely cautious in what you're doing. Energy is unforgiving. You only get one opportunity, and whack, that's it. It's game over. So don't get complacent. Be constantly aware of what you're doing, where your arms are at all times, and especially all tools. You don't want any tools, jumping between a positive and a negative, or, God forbid, touching any of these cables with that amount of amperage and voltage. Man, it's not going to be a pretty scene. So really stress to be careful. I'm not an electrical engineer. I'm a network engineer that has to do with communications between computers and satellites, stuff like that. I had to self-educate myself, and the first thing I self-educated myself was how dangerous electricity can be, but how fun it can be. Just be aware of what you're doing, how you're doing it, and why you're doing it, and then stress that 3 times over before you move forward, and you'll be fine.